And I believe you guys can do it. Haha. So, what we are doing today is we're just basically learning more about the 68K programming environment. Spoke to some people who actually knew a lick about assembly programming. So yeah. Gonna go with that. So basically the first part is we are going to do a simple hello world, and I know we found, if I minimize everything, you don't want to see that. We got the easy x86 thing, 68. I want to do x86 because I'm used to computer architecture. We're used to that. I'm used to that. But yeah, so 68K. So I guess just a 68K emulator, because I don't really have a cart. The Mac 68K AIM is software emulator built into all versions of classic Mac for PowerPC. No. Listed on this page are Macintosh. I don't want a Macintosh emulator. I just need a 68K emulator, right? What's this? Oh, no. Okay, assembler? What if I say assembler? Oh yeah, so this is... So I guess this would be the first thing, huh? Yeah, maybe I'll just, I'd have to do this and just kind of see what's happening. Yeah, I have no idea. Anyway, so there is the easy 68K, which we can program on, which is totes cool. But I want to go a bit. Is there a way to how to run 3 miles? To train for a 5K race with just over 3 miles, follow a weekly schedule 3 days a week for 2 months period. Week 1, brisk 5-minute warm-up. Huh, interesting. This is a wiki how-to, which means anyone can write it. Anyway, how to run 68000. Let's try this one, because I want to run it myself. I don't want to use an IDE. Right? I don't want to use an IDE. Okay, leave me the fuck alone. Wait, why? Okay, oh, you know what? We're going to do this. Because fuck this shit. I do not want to deal with ads. So we're going to install Ghosterly. Add to Chrome. Add extension. CRX file. Interesting. Okay. Whatever. Adding to Chrome. Come on. Just now add it to Chrome. Let's... Yes. Thank you, Ghosterly. Fucking... Oh, I know you have shit. 23. Let's, unblock all. Let's unblock all, then block all. There we go. Yes. Refresh. All right. Cool. We use an IDE and an emulator called Easy60K. Does it come with an emulator? CPU it's one of the most successful microprocessors, so used to today embedded systems. Installed 68K, ready to go. If you haven't, go install it and then write hello world and somebody's going on program. Okay, so I guess, yeah, easy 60K is just, I guess, is where I'm gonna start, huh? Try not to. That's fine. Let's download this. Yes. Fucking work. I'm just gonna run you. Unless you're already installed. Are you already installed? I don't remember. This installation is so old school. Look how old school this installation is. I guess I should also look at the README, huh? To know what the hell I'm doing. Notepad. Alright, look at this. Some nice ASCII art there. You need to create and run 68K assembly language programs on Windows PC. All programs and files are distributed under the GNU, General Public Use License. A copy of the GNU license is available in the help menu. Please see help for full contracts. The file extensions used by x86K are x68, which is 68,000 source code. S68, the S record file created by assembly and source. S record files are read by sim68k and may be executed. Listing file created by edit68k when the source code is enabled. Oh, I see. How do? Okay, I get it. So if I go like this, 68000k assembler. Unless like making an assembler is like much more crazier than I need. Right? Assembler. I remember this guy. So, is there a way to actually, like... How do you build it? Okay, so if I just open up this, right? File. Save as. I should have a Sega Genesis thing here, don't I? No, I don't. Oh, yeah, near, Genesis. In this YOLO. Save there. Go into here. Yeah, X68. If we edit, we get this. Cool. Wonderful. So now we go to a what? Assemble source. What's the assembly? Execute. Okay, that's cool. This is the window. That's cool. I like that, but how are you assembling it? I don't want to get into that. So how to assemble how because really, oh wait, what? This might be what I'm looking for. It loads. Ooh. The Crossware's S68000NT simulator creates a virtual S68 microprocessor on your PC. It allows you to run 68K programs without any 68K hardware match or and watch your code execute in Windows graphics environment. Hey, look at that. Wow, now. Try it now and buy now. Okay. 15-day evaluate. All right. So I guess that's something we're not looking for that. Okay. Because I just want to write in like source files. Well, no, I guess I don't. Do I? Because if I write my own assembler, then I have to figure out how it works. Do I really want to do that? Yeah, that's not what I need. No. Where would I get this? Where would I get something? Right? Compiling an assembly program with an ASM. Compiling assembly with an ASM may be done with Linux and Windows as an ASM is available for both platforms. As assembler and disassembler for the Intel x86 architecture, commonly used to create 16-bit, 32-bit, and 64-bit programs. An assembly will turn your low-level coding using mnemonics into machine language that can be understood by the processor. This article will not teach you how to program. Okay, so I need some called an assembler? 68000 assembler. .68K assembler. The program described here, 68K assembler, is a basic two-pass assembler for the 68K. It supports the complete instructions of both processes as well as modest but complete assembler source code format. The input of the assembler is a file containing instructions, assembler directives, and comments. It's getting really warm in here. Each line of the file may be up to 256 characters long. It is recommended, however, that the source lines be no more than 80 characters, as will guarantee that the lines do not exceed 132 characters in length. The assembler treats uppercase and lowercase identically, so there is no... it's case insensitive. Legal labels allow the rules for forming symbol names described in section 2.2. Labels may be distinguished in one of two ways, making in column 1, or they may end in a colon, which does not become part of the label, but simply serves to mark its end. Operation field, the operation... Why write a machine code chain for low-level languages and higher-level language? My microprocessor class gives extended write-in assembler in C. So it seems a bit logical to me. If I'm not wrong, assembling is the first step of the machine code to the journey higher level. I mean, C's will have blah, 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 blah. It's really long. People write assemblers to machine code. They've also written that in assembling language, often a subset of the language, they translate themselves. They have some bootstraps. However, none of this is necessary. In the end, an assembler is, as a usually fairly simple translation program. The fact that the text that's in input machine instructions... The Assembler Developer's Kit. As far as computer languages go, most of the languages have a fairly simple syntax. As a result, many programs have actually written their own assembler. Though many open source assemblers exist, and one could argue there's no real reason for writing an assembler from scratch, there are many benefits. Writing an assembler will give you program good appreciation and instruction coding. Writing an assembler will let you insert the features they want. Writing an assembler allows you to design a syntax. Unfortunately, there are disadvantages. Creating a hobby quality assembler isn't a difficult task, but creating a commercial quality assembler with professional features, such as a large project, often requires skills. Creating a modern assembler requires a lot of advanced compiler knowledge. Again, the most beginning. Is this an assembler for assembly code? Creating a fast assembler, one that others will want to use, requires a commanding knowledge of data structures and algorithms. It's easy enough to build a little toy assembler that works fine for small projects. It's a bit more difficult to get a high-performance system that handles large projects. While writing code to process individual machine instructions is fun and interesting, professional quality modern assembly requires lots of other code to handle declarations, data types, macros, and other advanced features. These features are not easy or obvious to implement. Purpose of the Assembler's Developer Kit is to provide documentation and source code to those individuals who are interested in writing a professional quality assembler. I might actually change this. I might just write an assembler right now instead. How do you make an assembler? I'd like to make one of those in tutorials. What you're looking for, assemblers and loggers. Interesting. So it seems like there's much more than I thought, huh? PCIe 4.0. Damn. This is okay. Interesting. Okay. Right, a higher language C is actually quite low, and I would probably prefer C++ system. A higher level language. Assembly language is actually totally unsuitable for a task like this. The cases where you would reasonably use assembly language are very, very rare. Only when you need to, things can be expressed in higher level languages. Okay. Interesting. Okay. I see. Interesting. And see, this is what people do in work, guys. They're like, if there's a problem they can't solve, they'll go around and talk to people and figure things out. You know, it's just basically what I'm doing. I'm going really deep into maybe just making an assembler. Because it'll be fun. Why the hell not, right? I've read that learning a low-level language should provide higher level languages. However, I don't know how to get set up. If someone said to me, I want to learn VB.NET, C#.NET, how to do it, yes, okay. Is to buy Raspberry Pi and follow this tutorial. Another option is buy this book. It comes with the live CD already, so to start tinkering, which you may download for free here. 68K assembler. At first, it seemed fairly straightforward to me, but the more I read it, the more unanswered questions I have for myself. There's an excellent free ebook on how to build assemblers and loaders. Oh, there's an ebook. Might have to read this. Assemblers and loaders. Covering the design and implementation of assemblers and loaders, this comprehensive book opens with an introduction to 1-pass and 2-pass assemblers. Important concepts such as absolute relocatable object files are discussed, as are assembler features such as local labels, multiple location counters, the format, meaning, and implementation of many directives that look in detail in the important topics of macros and conditional assemblies that are introduced. The latter part of the book is concerned with the listing file properties. 300-page book. This is insane. I hate reading on fucking computers. It's better to have a book. I mean, of course, although I tell people like, hey, just go and do things. That's it. An assembler is a translator that translates source instructions into target instructions on a one-to-one basis. This means that each source instruction is translated exactly. So if I am on a Intel CPU, I need to if I'm just so there's that. Okay, so basically we're kind of we have the assembler, which takes the 68K assembly language, right, and puts it into machine code language. But then there is the part of, well, once I take the machine code language, how do I actually emulate that? So the emulation will come later, right? One reason for studying assembly is that its operation of assembly relies on the architecture of the computer. I get that. I mean, would I want my own assembler? Am I going too deep in the rabbit hole here? Because the more stuff I want to make, the longer this is going to be. But I know everyone here loves me anyway, so. One that performs all its function by reading the source file once, source file twice. One that permanently load memory, typically such as assembly resides in a ROM, is very simple. A macro assembler, a cost assembler. So I would need something that can basically read the source file and go, okay, cool. Here we are. Here we are. Take this line, turn to a bin file probably, and execute the bin. As mentioned in the instruction, the main input of the assembler is the source file. Each record on the source file is a source line that specifies either an assembly instruction or directive. A typical source line has 4 fields: a label or a location, a mnemonic, an operand, and a comment. Loop, add, R1, ABC, producing the sum. In the example, loop is a label, add is a mnemonic, meaning to add. R1 stands for register 1. ABC is the label of another source line. R1 and ABC are 2 operands that make up the operand field. The example above, therefore, is double operand instructions. When a label is used as operand, we call it a symbol. Thus, in our case, ABC is a symbol. The label file is only necessary if the instructions is referred to some older point in the program. The word mnemonic comes from the Greek blah. Comments. Columns 1 through 6 is the label, 7 is blank, 8 is mnemonic. The operand must be separate from the mnemonic with at least 1 blank and must start on or before column 16. The comment must be separated from the operand by at least 1 blank. If there is no operand, the comment may not start before 17. The comment extends through column 80, but column 73 are normally used for sequence and identification. It is often very hard to center source lines from a keyboard. Modern assemblers are thus more flexible and do not require any special format. If a label exists, it must end with a colon. Otherwise, the individual fields should be separated by at least one space. Semicolon guarantees that the word enable will not be considered an operand by the assembler. This is why many assemblers require the comment start with a semicolon. The instruction sets of some computers are designed such that the mnemonic specifies more than just the operation, also contain part of the operand. Okay. To translate an instruction, the assembler uses the opcode table, which is a static data structure. The two important columns in the table are the mnemonic and opcode. Table 1.1 is an example of a simple opcode table. It is part of the IBM opcode table. Mnemonic A is the operation code 5A, AD is 6A, ADR, AER, and AE. The mnemonics are from 1 to 4 letters long. In many assemblers, they include many digits. Okay. So I guess take it and just change it to fucking hex. I could also just write hex as well. Okay. In similar counters line that it forms two independent operations. It stores XYZ in the value. Okay, so now basically it's we take the instruction set. And the question is now, what do we output? That's a good question. What the hell do we output? Source line, the 2-pass assembler, 1-pass absolute, 2 historical notes, forcing upper, absolute relocated, local labels, multiple location counters, literals, attributes of the symbols, assembly time errors, review question projects, the symbol table, a linear array, a sorted array, buckets, binary search tree, hash table, directives, introduction, source programming, subprogram, error control, listing, remote, macros, summary, review question. So a 6800 example. So I'm skipping a lot of stuff. And the reason why, it's like, I'm not gonna need it yet. You know, I'm not gonna have to worry about macros right now. For the simple thing that I'm doing, not simple, but for the start, you know, for the start, excuse me, for the starting, like on overboard macros, craft over like one easy instruction, that's it. Disassemblers, cross assemblers, assemble go loaders, absolute loaders, linking limit, multiple locations, bootstraps, a survey of some modern assemblers. Macintosh references the dressing modes. So I'm assuming it's just an EXE, right? That's what I'm guessing, is just a regular like EXE. The operand from assembler can consist of an object model, a program listing, terminal messages, and associated data file. The object models can be written to a data set residing in a direct access device or magnetic tape. You specify the GOF assembler, okay. Block all, motherfucker. Computer science, an assembler is a program that turns assembly language into machine code. An assembler is a program that takes basic computer instructions and converts them into a pattern of bits that the computer processor can use to perform its basic operations. Some people call these instructions assembly language, and others use the term assembly language. Most computers come with a specified set of very basic instructions that correspond to basic machine operations that the computer can perform. For example, a load instruction causes the processor to move. I see. So I'm confused. Wait. I'm really confused. So if I have the mnemonic and I write it in a source code, then it gets translated to machine code. Because machine code doesn't understand the mnemonics, but it's the closest because one line of assembly goes to one line of source code, machine code. So my next question is then, if I'm writing the assembler, could I decide what my mnemonics are? Like, because if I'm going to write the translation layer from assembly to machine code, I know what I'm looking for. Right? Now, I'm assuming the mnemonics that are used are the ones that are in like the 68K programming manual. I think that's what it is. The assembler program takes each program stream and source code and generates a corresponding bit stream of patterns. The output of the assembler program is called object code or object program relative to the input source code. These sequence of 0 and 1s that constitute the object programs is something called machine code. The object program can then be run or executed whenever desired in the earliest computers. Programmers actually wrote programs in machine code. Language instruction set a particular computer architecture. Okay. Yeah, if I'm writing my assembler, executables and link. Oh, executables and Lincoln format. A relocated ELF file produces assembly consists of an ELF header. Okay. An ELF header is always the first part of an ELF file. It is a section of the fixed size and format. Oh, interesting. Okay. All code is generated via special linked lists of instructions. That cheetah is like really fucking annoying me. Okay. Okay. I really love it when I'm looking through things and I find like and I find like references to college, because I'm not in college anymore and I'm very happy I'm not in college anymore. Anyway, so if I write a assembler, can I define the mnemonics? I don't think I spelled that word right. Programming as binary machine code is really no fun. Consider programming in a text lab machines. What does this program do? First instruction is at 0. We call from the text that each instruction operation and corresponding name. This is called the opcode mnemonic. The noun mnemonic means devices and techniques to improve memory. When you apply mnemonics, the code result is load, add, store, compare, jump, get, store, jump, load, subtract, store, out, halt. Why not assign load mnemonic to the last 5 instructions? Because it turns out that they are not instructions, but data. You can't easily see this by looking at the machine code, but could probably guess based on its operands and the few instructions. The software that performs translations is called the assembler. If you like, we can write the numbers in decimal to get rid of the leading zeros. You'll probably find this a little more readable than the hexadecimal version. This is a good time to explain the logic statements of 3 and 4. Statement 3 compares the contents of address 6. Okay, that's fine. Okay. Appreciate higher leveling. Here it is in Java. Int A is 6, int B is 7, int C and D. C equals A plus B if C is greater than or equals 0, D equals C, else D equals negative C. System to print out D. Though this running example, we can encounter several duties if it's simpler. Translating opcode mnemonics to binary. Translating numeric values to binary. Handling labels, handling pseudo operations. The assembler must do a couple of things. As each machine language instruction or data is generated, increment a location count to keep track of the address, where the current instruction data is to be stored in memory. Okay, cool. So basically, I think, yes, I can decide technically what mnemonic I want because I'm the one going to be reading it, but fuck it, whatever. We're not going to do that. So now, if we go to 68000 assembly, no, 68000, hey processor, instruction set. We get this. The standard addressing modes are register direct with the D0 and address direct, register indirects. Well, we're going to have some fun, shall we? We've included this appendix to save you the... Oh, hey, guys. Do you remember last episode? I was looking at one of these things and I found like a 700-page PDF. So last week I had lunch with my teams and I mentioned how to kind of start doing this just because I was curious and never done it before. Well, one of the person there, his name is Hart. He's been programming for like 25, 30 years. It's really cool. But he actually mentioned the 68K and, manual. I'm like, oh, it's like 700-page book. And he's like, yes, exactly. So it's really cool that I was referring to something that he used way back in the day. All right. We include this appendix to save you the task of having to turn to secondary materials on writing 68K assembly language programs. Since most programs are not interested in coding of instructions, details of instructions and coding have been omitted. Instructions are listed by mnemonic and alphabetical order. The information provided about each instruction is its assembly syntax, its attributes, whether it takes a byte, word, or long word, its description of words, the effect its execution has on condition codes, and the addressing modes it may take. The extent of an instruction on the CCR is specified by the following codes. The state of the bit is undefined. The bit remains unchanged. The bit is set or cleared. Using an addressing mode is implicit. The legal source and destination addressing modes are specified by their assembly language syntax. The following notations is to describe 68,000 instruction set. DN or AN is data or address registered direct. Parentheses AN is address registered indirect. Addressing registers indicate with post increment or post or pre. Oh my god. ABCD. Add decimal with extend. Destination source. Add. Okay. Add binary. Probably add is what we want to start with. So once we take it and put it into machine code, the next part is actually writing something that will read the machine code or the executable and do something about it, right? So, oh boy. It's 30 minutes till 9. We've only listened to 40 minutes, guys. We can keep doing this. So I need to keep talking or keep thinking or else I'm gonna stop because it's late for me right now. Add EADN or add DNEA. Size is equal to byte, word, or long word. Add the source operand to the destination operand and store the result in the desired location. Computational code X, N, Z, V, and C. Source operating address modes. I can't even fucking read that. Let me just zoom in. No, they're still horrible. Destination operating adjustment modes. Okay, fine. Cool. So now 68,000 manual, which is a ginormous 700-page book. If I download this and put it into Sega Genesis, right? Boom. If I download this and also put this into the Sega, my laptop's doing just fine. I guess it doesn't matter since no one the fuck is talking to me anyway. God, guys. Talk to me. Talk to me. I want to know your feelings. I want to know your emotions. What's bugging you? How do I even make an emulator anyway? Right? I mean, that'd be great if there was a fucking 68000K emulator. I don't want easy 60K. No. No. Bad. Starscream, the 68K CPU emulator was written by Neil Corlett to be compiled with an ASM, among others. Rain uses the CPU core. This is a modified version of Starscream made by Stack Fane, the author of Gens. It fixes some bugs from version 0.26a and is beginning with version 0.26b. Turbo 68K. A Motorola 68,000 processor emulation library for Intel x86 and compatible processors. Turbo 68K, originally developed for the new project, is now available to the public. Not only is it fast, being optimized for Pentium and as assembly language, but it's also accurate. Okay. A Motorola, okay. Extract files. It shouldn't be that big. It's a C program. So we're gonna have to like fucking... Currently emulates 68,000 microprocessors written for Intel x86 Pentium or better. Originally designed for Gens, now available public use. Terms of use. Table of contents. Making. The Turbo emulator is usually distributed in a compressed archive. Simply extracting, you should have the C, H, and this text. First step is to get the source code emitter. Make 68K up and running. It should compile with any 32-bit C compiler. Compilers other than GCC will often produce warnings. These can be ignored. The following have been confirmed. If you get link errors concerning PAL, make sure to include the appropriate math library. Once make68 has been built, run with the name of the file you wish to emit on the command line. For example, make68K. Okay. So this is a C file. Oh, it's just literally a C file. That's so crazy. Oh, boy. Jesus Christ. Actually, making my own emulator seems kind of fun right now. Why is this E? E. Why are you using just a one-word thing? Void E. Emit. Interesting. So basically, what I'm thinking is the emulator. I bet you can't even see me, can I? I'm sorry. This emulator basically takes the machine code, right? Takes the machine code that I've made and basically does stuff with it, right? So I can load it in. So read long E, read byte, read word. Why E though? Is it just to keep it slow? How many lines is this? All right. Interesting. All right, so I need the C compiler. CC. Awesome. Darren at Darren PC. Oh, how do I get out of here? Where am I? Linux. Am I in Bash? Yeah, Bash. Segwin terminal. Segwin. There's no direct name desktop in your current directory. Linux has a different philosophy, and you can't go desktop this way from every place. You can instead go to home directory by typing CD from every place to the root directory by typing CD that. From every place. You can think about that. Okay, hey, I get to learn some Linux. Lucy, do you want to go out? Hold on. Puppy. Hey. Sorry, puppy wanted to go out. You can get instead into home directory by typing cd tilde from every place into the root directory position cd that. Okay. Place. You can think of it as the way that Linux uses home directory instead of desktop. Every other time you have to cd to an absolute path or relative path. For example, you're in directory home ninja. You can get to current by typing pwd. You type ls. Console logs all directories, which you can now go into by typing cd, e.g. the console logged. Additionally, no matter where you are currently, you can use cd/ and cd that. Okay, LD. What? Fuck you. Hey, I did something. Hey, look at that. This is Linux, so I believe Linux is case sensitive. 68K060 dir cc make 68K. Air spawn, no such file or directory. Yeah, I'm compiling this, right? Oh no, I have to link to the H, don't I? Edit. Yeah, I need to link to here because if I go turbo 68K, right? If I go all the way up, I'm glad I know my C and C++. Math, SDR, SDI, IDEOS, lib, yeah, turbo 68K. Okay, CC, fuck. Type GCC version percentage should return the version of the GCC -- version. Uh, 740. There's no warranty. For example, if your source file main.c is located in use, okay, fine. Replace main.c. Oh. Only the most useful operations are listed here. When you invoke GCC, it normally does prepare compiler, assembling, linking over options. Yeah, other options. Most command line options that you can use are useful for C programs and options to another language. Okay, that's fine. What time is it? 8:44. GCC is to run the executable called GCC or machine GCC when cross-compiling. No, that's fine. The GCC program accepts options and file names it operates. Many operations have multi-letter. You can mix them. Options. ANSI, SC equals standard. Oh my god. Do you have just examples? What am I doing? Right, I'm doing the emulator just to see kind of what it looks like. Yeah, that's what I'm doing. No! Fuck this. No, I'm gonna make my own. Yes, close anyway. I'm gonna make my own. You know what I'm gonna do? You know what the fuck I'm gonna write my own. Why am I gonna write my own? Because I can. That's why. Because I fucking can. So here's what we're gonna do. My password is secret, guys. You don't get to know what it is. Alright, well, considering you guys are going to see my code, I'm not going to put it up on here. I'm going to use my laptop instead. There's no point in using this code if you guys can fucking see it. No, I don't want to do that. Oh boy, so I'm on my laptop right now. My repositories, 68K. New. 68K. Create. There we go. All right, cool. So, still technically can't log on. /me /68k.get. That's fine. I don't care. Right? Cool. So now I'm here. So now we can do anything you want, guys. We can do whatever the hell we want, which is pretty cool. So we can make first a program that reads a line and turns it into something else. So we are going to do this. No. Get. There we go. Cool. It'll be fun because I have no fucking clue what I'm doing right now. And that's okay, guys. I have no idea what I'm doing, and that's fine. It's totally fine that I don't know what I'm doing. That's one thing with learning. You just got to go. You just got to jump straight into it. And that's how it works. You just got to fucking jump around. Jump around. Jump up and jump down. Whatever the fuck that is. Console app. We are going to put you in C. Get 68K. Select folder. I see. That's fine. We can do that. We are going to call this the 68K assembler. Don't think it should. I mean, it will be pretty fucking complicated. I'm not gonna lie. This is gonna be really goddamn complicated. Man. Guys. Fine, don't respond to me. See if I like you or not. Alright, so. This is the assembler. Numbers can't. Alright. I get an underscore. That's fine. It's really weird to be programming in C# right now. I'm doing C++ at work, so it's really weird to be doing this in C# right now. But that's fine. So basically, what we need to do is take this, not that, edit. Oh, I did not mean to edit that. Go away, go away, go away. Hey, Haskell. All right, we're going to go up here. And that instruction set. Oh, I need those opcode patterns. I need those opcode patterns. Give me those fucking opcode patterns. No, don't fucking fuck. God, I need to stop opening everything in Notepad++. Figure 1 illustrates the integer portion of the user program model and consists of the following registers. A 16 general purpose 32-bit registers. Figure 1.1 illustrates the integer portion of the user programming model. It consists of 16 general purpose 32-bit registers, D7 through D0 and A7 through A0. 16. Wait, what? Hold on. Oh, D0 through D7. Okay. A 32-bit program counter and an 8-bit conditional code register. These registers are for bit and bit fields. 1 32 bits. A byte is 8 bits. A word is 16 bit. And a long word 32 bits. And a quad word is 64. I should write this down. Let's go right. All right, byte 8 bits. I mean, I do know a byte is 8 bits, but a word is 16 bits. Word is 16 bits. Long word is 32 bits. Long word is 32 bits. And a quad word is 64 bits. Quad word is 64 bits. Save. Address registers. These registers for bit and bit fields. These are just going to be used as software stack pointers, index registers, or base address registers. The base address register is going to be used for word and long word operations. Register A7 is used as a hardware stack pointer during stacking and subroutine calls and exception handling. In the user programming model, A7 refers to the user stack pointer. The program counter contains the address of the instruction currently executing. During instruction execution and exception processing, the processor automatically increments the contents or places the new value in the PC. For some addressing modes, PC can be used as a pointer for PC relative addressing. Consists of 5 bits. The CCR status register's lower byte is the only portion of the status register available in the user mode. Okay. The first 4 bits represent... Oh, I remember this thing. This is from the other thing. Extend. So this thing... Oh, okay, I get it. Okay. Floating point user programming model. The following paragraph describes the register for the floating point user programming model. Is there programming models? So I see this is for integer. Ooh. Okay. Why are there different programming models? This is interesting. God, we are just getting in like a... So the integer unit user floating point supervisor programming model. Integer data formats, floating point data formats, floating point data numbers. So, I mean, we basically just, so we need, this is, so here's the goal. Here is the goal right now. The goal is to take an add instruction. Put it into machine code. Have a Sevit program. Take that machine code and do something with it. Now, we also need to try our best to do in the context of this, which will be fun. I have no idea how to do this. I mean, I could write a C# program to read in the binary and just put something on the screen. I could if I wanted to. And I don't know. I mean, just a lot of this, I have no idea what I'm doing. And that's fine. And that's okay. It's okay to not know what you're doing. And that's fine. You just gotta go. And it seems like this is gonna take me quite a while. The manual contains the software instructions used by the micro and core processors. Yes, phone, I know, leave me alone. User programs executing the user mode only use the registers in the user group. System software executing the supervisor can access all registers and uses the control register of the supervisor group. The following paragraphs provide a brief description of the registers in the used and supervisor's model as well as the data organization. Okay, this is for integers. And then floating point. The following paragraph describes the registers for the floating point unit user programming model. Figure 1-2 illustrates the M6008 family. Okay. Interesting. This is really interesting. All right, guys. So, thank you all so much for joining me. I'm getting farther, so it seems like I could use the EZ68K to write a program and emulate it and have it running. I could do that if I wanted to. But I really don't want to. I want to get my hands dirty in this. So I'm going to write a program, the assembler, that takes my mnemonics and transforms them into machine code, binary. I am then going to take that binary file and read it and do things that I need to do with it. It doesn't have to be pretty. It can be something. It can be whatever I want, as long as it reads them. I guess is okay. However, once we get to the Sega Genesis, that'll be been interesting. So this is a great project. I'm gonna be doing this for quite a while to come. I'd love you to be with me on this adventure. But anyway, so this is me, that programming guy. I stream every Monday at the moment from 8 o'clock at night to 9 o'clock at night every Monday, standard time. I also release a video every Sunday for that programming guy for Practice Makes Better on YouTube. Check that out if you want to. Currently, as of June 3rd, 2019, what I'm doing is Haskell. Yeah. Everyone, thank you all so very much for watching, and I will see you all next week. Bye.